The 7.1 quick check starts off with asking about the half reactions for aluminum and magnesium. So if we were to write those out, we just say, okay, aluminum, these are always reductions. So I'm going to start with the aluminum ion. And since it's 3 plus, I'll add 3 electrons, and I'll become aluminum metal. And then for magnesium, I'm just going to write magnesium ions plus 2 electrons become magnesium metal. So we're kind of working on just what's the pattern here. Now, the next part is really critical. It says a piece of aluminum is placed in 1 molar magnesium nitrate and no reaction occurs. No reaction occurs. So here's where, so what are we talking about? We're talking about magnesium ions, and we're talking about aluminum metal. So the situation here is, what do we know about the reduction potential of the aluminum? Well, if aluminum metal and magnesium ion does not react, that means that the order that I've drawn them here is actually correct. Because this is saying that for this reaction to occur, my aluminum would have to be oxidized and my magnesium would be reduced. And so aluminum, since it's not happening, aluminum must be the higher reduction potential, because if I had put together aluminum ions and magnesium metal, that would happen. But aluminum and magnesium ions, that's not occurring, so I know that this order is correct. So I know that the aluminum has a higher reduction potential. So what do I know about the reduction? Okay, I know that aluminum reduction potential is greater than magnesium's reduction potential. Now, further than that, I can go back and say things about, okay, well then, if I'm going to make a cell out of these two, then this one, because it's the higher, aluminum is higher, then I know that that's going to be my cathode, that's going to actually do reduction, and that this is going to be my anode. Okay, for sure. And I also know that the anode reaction is going to be magnesium metal turning into magnesium ions. Anyway, so let's go. So the E of the cell, E cell for a cell made from aluminum magnesium is positive 0.74 volts. So what is the reduction potential of aluminum? Well, I do know that, okay, the E of the cell is equal to the reduction potential plus the oxidation potential. And what do I know? I saw that the reduction potential of magnesium is negative 2.37. Well, I know my magnesium is not going to be the cathode reduction. It's going to be the anode. So my oxidation potential, I know, is going to be positive 2.37 volts. And I know the E of the cell is positive 0.71 volts. So I'm going to figure out what is my reduction potential of aluminum. Now it's just a math question. So positive 0.71 equals X plus 2.37. So that means that X is going to have to be negative, and I can just solve for X. So X equals 0.71 minus 2.37. Okay, to solve for X, and that comes out to be 1.66, negative 1.66 volts. And so that's my reduction potential for aluminum, negative 1.66 volts. Okay, electrochemical cell. Now, sketch the cell made from gold and copper. Okay, so gold and copper, here are my two numbers, and I just know now that my larger number, that is going to be my reduction, that's going to be my cathode, and that my smaller number is going to be my anode. And let's do the anode. So the anode is going to be this reaction reversed. So the anode reaction is copper turns into copper 2 plus 2 electrons. Okay, my anode is going to be as is, so I'm going to have gold 3 plus 3 electrons, turns into gold metal. Alrighty, what's my overall reaction? Okay, I've got 3 electrons in this case. I've got 2 electrons in this case. So when I put this together, I'm going to need to go back and multiply this by 3. So I'm going to have 3 Cus turn into 3 Cu2 pluses plus 6 electrons. And on my other side, I have to multiply this by 2. So 2 gold, 3 pluses plus 6 electrons turn into 2 gold atoms. And everything on the left, okay, my 6 electrons are going to cancel. So make a note, if I needed to do a calculation, n would equal 6. And my final equation then is going to be 3 copper metals plus 2 gold ions turned into 2 gold metals plus 3 copper ions. Okay. Which electrode is losing mass? Well, let's draw it out first. Okay, so what I'm going to have is I'm going to have a solution over here and a solution here. And in one solution I have a piece of metal, the other solution I have a piece of metal. That's my standard starting point. Okay, I'm talking about gold over here. So this is gold metal in a solution that has gold ions. So, you know, it could be gold nitrate or something like this. I'm going to say 1 molar gold, Au3 plus. That's a U. And this over here, this side would be a piece of copper metal. And it's going to be in a solution that's got 1 molar copper ions, Cu2 plus. And I'm going to connect these two with a wire on the outside. Okay. I know that my electrons are going to be flowing from my anode to my cathode. And I need to have a salt bridge in between these two. So let's change the color. Let's get a blue one. So salt bridge, I just need something that allows my ions to flow back and forth and keep the solutions electrically neutral. And so sketch the cell. Okay, so I think actually I have everything on here that I have to have in order to show this reaction. So copper in a copper ion solution, gold in a gold ion solution. I'll have my salt bridge to keep everything electrically neutral. If I wanted to go further into what's going on, okay, I would know that my anode, my negative ions, are flowing toward the anode, and then my positive ions are flowing toward the cathode. Okay, but you know, they're not asking for that. Okay, so which electrode is losing mass? Which electrode is losing mass? Well, here I have my copper metal turning into copper ions. So the copper side, that's the one that's going to be losing mass. Because where's the mass going? Okay, it's going into the solution. Because the copper metal is going to be, you know, going away bit by bit. So this is going to get smaller and smaller and smaller as the solution, as the copper ends up in the solution. So I can be able to visually see that because my copper solution is probably going to get bluer and bluer and bluer. So the copper goes there. Now, when we did this, this was a similar question they asked on the AP exam. And what it said is, you know, where's the mass going? Because copper is losing electrons, there were people that said it is, you know, the mass is going because the copper is leaving, you know, through this wire and going over to the gold side, you know, and that's wrong. Okay, that, you know, it is true that the electrons are, you know, going from the copper to the gold, but, you know, electrons hardly have any mass whatsoever. You know, where the mass is really ending up, it's ending up over here in the solution. Okay, so where's the mass going? It's going into the solution as copper ions. And that's the quick check.